Welcome to TTLinks. I'm thrilled to share an exciting update on the progress of TTLinks. This is my open source project. In my daily work, I often need to automate some network tasks and wondered if there was a way to build my own packets and protocols. After trying different libraries, some well-known ones like Scapy, I found that their licensing term and features didn't fully fit my needs. That's why I created TTLinks. This is a library designed for all kinds of network automation needs in the future. Today, I'm so excited to announce that TTLinks can now build Ethernet frames, IPv4 header, and TCP packets from scratch. I will show you how easy it is to use. Just a quick note, TT-Links only works on Linux because it requires raw socket access, which Windows restricts. Although you can try running on Windows, but the package won't actually be sent even though it's showing successful. Without further ado, let me show you what you can do with a new feature of TT-Links. If you are familiar with the network protocols, IPv4 and TCP are the protocols we will hear every day in our work. For your reference, the picture above is IPv4 header, and the one below is the TCP header. What the TT-Links new feature does is to let users to build our own packets as flexible as possible. Let's take a look on the code itself. You can set any field in the IPv4 or TCP headers. For instance, in the IPv4 header, you can modify the identification, the SCP, which can be used for QoS, source address, destination address, TTL, or other fields included in IPv4 header. Also, you can customize the TCP header, such as the source port, destination port, sequence number, TCP options, or other fields included in a TCP header. While building a packet, many fields can be ignored, as TT-Links will auto-generate them to save you some time. Like the IPv4 identification field or TCP sequence number field. The checksum fields for both IPv4 and TCP are automatically calculated for you, so there is no need to set them manually. But you can if you want. Here is a quick demo of building a TCP sync packet. Sync packet is the first packet of a TCP flow. Here we can set the IPv4 don't fragment bit. Also, we set the TTL to 32 and specify the destination IPv4 address. The source IP address will be filled automatically based on your system's routing table, so we can skip here. Again, you can set it if you want. Then we specify the source port, or let TT-Links pick up a random available one for you. Set the TCP sequence number. Mark the sync bit since it's the first packet of a TCP connection. After setting these fields, you can generate the packets as a bytes format, ready to be sent using Python socket module. TT-Links makes this simple. With only a short piece of code required to create and send a packet, I've created a function that uses a raw socket to send the packet. Remember, this method only works on Linux. On Windows, this function will run but won't actually send the packet. Now let's look at the Wireshark. You'll see the packets we just sent, with all the fields matching the values we just set. This feature is actually a prerequisite of the next big feature for TT-Links, which will be the TCP port scanning. Building custom packets is essential for this. And the TT-Links gives you the flexibility to create network applications in Python without needing to make your code open source. TT-Links is licensed under MIT, so you can use it freely in any projects. That's it for today. If you have any feedback, suggestions, or challenges you are facing in your work, please leave a comment. Since TTLinks is still in its early stages, I'd love to hear what features you'd like to see. Your input helps guide future development. Thanks for your support and have a great day.